Right, we're going to look at some functions here. Functions just being number machines. Our f number machine takes our x values, times them by 4 and subtracts 1. And we're allowed to put any x values in bigger than 0. That's a domain. Our g function takes values of x, squares them, then adds 3 to get its output. We're allowed to put any value of x we like in. X belongs to the set of real numbers. Evaluation then. F of 3. We swap 3 for x. And we end up with doing 4 times by 3, take away 1, which is 12 take away 1, 11. Similarly, g of 2, swap 2 in here. 2 squared is 4, plus 3 is 7. F g of minus 1, it's a short way of writing f of g of minus 1. So the first thing we need to work out is g of minus 1. So let's do that over here. G of minus 1 is equal to minus 1 squared. Put the brackets around the minus 1 if you're using your calculator, which minus 1 squared is 1, plus 3 is 4. So we end up doing f of 4, swap that into there, 4 times 4 minus 1, which is 16, take away 1, 15. Same idea here, but we have to do f of 1 first. So f of 1 is equal to 4 times by 1 minus 1, which is 3. So then we're working out g of 3, which is equal to 3 squared plus 3, which is equal to 12. So, with the composite functions, you work from the inside out. What's the minimum value of g of x? Well, there's loads and loads of values we can get out of g of x, but we need to find out what's the smallest possible value. And it all revolves around the squared bit here. If you think, well, when you're squaring numbers, the smallest answer you can possibly get is 0, because negative numbers squared are positive. So the smallest value of x squared is 0, so x squared has to be bigger than or equal to 0, so therefore g of x has to be bigger than or equal to 0 add 3, 3.